Here we have the equation of a rational function, graphed in our graphing calculator. X squared plus 7x minus 30 over the polynomial 2x squared minus 11x plus 15. If we graph this polynomial, we see that we have this visual. It's clear that there's some kind of asymptotic reaction happening here, somewhere in this space. To the left of that space, the function decreases without bound. From the right of that space, the function increases without bound. But somewhere in here, there's some kind of asymptotic behavior. We want to be exact about where that asymptote might be. So we re-express our polynomial in its factored form. In the numerator, we will factor the polynomial x squared plus 7x plus 30. And we will rewrite that as x plus 10 and x minus 3. In the denominator, we will factor similarly, and its factored form is x minus 3 and 2x minus 5. Now, to convince you that they are the same thing, I'm going to graph this, and you're going to see them right on top of one another. That's not necessarily the intention of this. Basic factoring from algebra will tell you that those two are equivalent to one another. But what I'm much more interested in is what's happening in the denominator of this factored form. If we think through our restricted values, we have two restricted values for this polynomial, or for this, this rational function. We have x is equal to 3, which comes from the first factor, and we have x is equal to 5 over 2, or 2.5, which comes from the second factor. We should anticipate strange things happening in the function on in those locations. So if we go back to the graph, and we'll start with x is equal to 3. If we press trace, and then we type the 3 in directly and press enter, we see that the function has no value at that location. But if we press trace, and we scroll across the function, we see that around 3, it does have some value. And I can continue to go left around that point, and it has value around the number 3. If I continue to go to the left, you'll see that I jump into the negatives. So somewhere in there, something interesting is happening as well. And that comes from our second factor. So go back to our factored form and scroll all the way down. We have our other factor of 2x minus 5 contributing x is equal to 2.5 to our restricted domain. So let's go back into the graph. We'll trace one more time. This time we'll enter 2.5, and we'll see that it has no value there either. So yes, 3 and 2.5 are limiting us in some way. They are restricting our domain. But they are not necessarily restricting our domain in the exact same way. If I go to the left of 2.5, you'll see that I have strong negative values. And if I go to the right of 2.5, you'll see I have strong positive values. That's an indication to me that there's an asymptote happening there. But if I go trace and 3, and I scroll around my 3, I'm staying in that positive territory, which is an indication to me that that's not an asymptote. There's no asymptote at 3. Something else must be happening, and that's our relationship where we have our hole, or what's sometimes referred to as a removable discontinuity. You need to be careful when it comes to those restricted values, and that's the purpose of this lesson, identifying when each one will occur given the nature of the function you are graphing.